First off, I'm Sam Gage. Fonts, good fun. Ignore that. So I'm the lead technical designer at the third floor in their immersive department. That's basically, we cover everything that's sort of AR, VR on the consumer side. Does it click at work? Yep. So this is the sort of things that I've worked on, a sort of bunch of range of hardware, the Wii, the PlayStation Move, the Wonderbook, if anyone remembers that, PlayStation Move, PlayStation VR, and obviously the Oculus Rift and the Gear, the HTC Vive. I forget what they're all called, there's too many of them. So the third floor where I work is a visualization studio, so that's basically they make animated storyboards for Hollywood. They do a lot of other things, sort of on-set logistics, basically anything that you can visualize with Maya. This is the team, they're all lovely people. They work on lots of films, which are all great. So I go through the company. There we go. So these are the things that we work on: films, TV, themed entertainment, that sort of theme parks. They do a lot of pre-visualization of what theme park rides are going to look like. This is our interactive team, and here's a little video just to show you the sort of thing that we get up to. Linear experience, and we've got a lot more interactive stuff, which we're going to be sort of talking about today. There's some virtual camera, so what that is using the trackers from the VR kits to track an iPad in real space, and you can use that as like a camera to look into a virtual world and film things. Also do sort of set scouting, location sort of things like that. And let's get to the meat, right. So, these are the services that we offer, and VR full production and interactive prototypes is what we're going to concentrate on today. So, I want to talk about how it is that we go about understanding the real world and how that people interact with it, how we then go about simulating those interactions in the real world, in the virtual world, and then creating a framework whereby designers can come along and sort of prototype things and not have to do a ton of technical implementation every single time. So first, I'll sort of cover what I think VR design is. Here's a bunch of stuff which VR design is, and it's a lot more. The bits that I cover are the bits in bold, sort of game design, industrial design, interaction design. So we approach it basically by looking at it as though it was the real world. There's a picture from a whiteboard. I spend quite a lot of my day either doing that or just playing with things like kettles, which I'll talk about in a second. So I'm going to cover a couple of design concepts. The first one's affordances. So here's the example of a kettle. So when you're looking at an object, what you want to be able to do is break it down into how the user's going to be expecting to be able to interact with it. So take the example of a kettle. It's got various things you can do with it. You can fill it with water, you can turn it on and off, you can open the lid and close it. Those are all affordances. They're things you can do. Hiding behind it, it affords cover. If you want to hide behind a kettle, it's not very good at that. But an affordance is essentially any interaction that a person has with an object. Signifiers, they're the things that tell you how you can interact with the object. So, for example, the spout at the front, that's a visual signifier to say this is where the water comes out, the handle's on the other side, so that's going to tell you that's where I need to grab it in order to pour the water. And that's very important because you need to make sure that when people go to grab at a kettle, there's an expectation that the handle is going to be where they're going to grab it, and they're not going to try and grab it at the top. That would be kind of weird. So because the controls in VR are a little bit clunky compared to real life, you want to make sure that you're doing what the user expects and not just sort of accurately, like physically what would happen if you pincered the hand at that point. So here's a couple of slightly more obvious signifiers from Shattered Memories, Silent Hill Shattered Memories, and the London Heist. So what we did was basically color things red if you can interact with them. It seems kind of straightforward, but actually it does really catch the eye, and it's kind of a nice way to differentiate between the things that you can and can't interact with, particularly if there's things that you could interact with in your playing space. Hidden affordances are affordances without signifiers. So you could throw the kettle at a zombie, for example. That's a good example of something that the object isn't designed to do, but that you can do with it, and you want to also make sure that anything that's kind of obvious in that respect is supported. A bad example would be that you lift the kettle up by the switch, so the user comes along and they flick the switch on the kettle and the whole kettle comes moving with their hand. That's going to be annoying. That's probably not something you want to simulate, so you'll just have the hand sort of disconnect when it goes too far away. So you always want to sort of take into account what they're trying to do, as well as the fact that they've grabbed hold of these things. A signifier without an affordance. That's a false affordance. So bottles are it's very important that you make sure if you have bottle caps that you can unscrew them, because otherwise people will pick them up, they go to grab, and they've lost their immersion, bad times. Or just sort of, so as I say, if you don't implement functionality, just keep it out of reach, or make it very visually clear what the difference is between things you can and can't interact with. So here's a quick example that we can break down again. So when we're going through the design process, we'll look at every single object on the scene and say, what are the constituent behaviors within this? So a bottle, the body, you can pick it up, so you need to be able to attach it to the hand somehow. And the cap, it can be twisted off, so it's sort of a different behavior, but it's still attached to the hand in some respect. So this is actually a very useful resource. I recommend writing that one down if you're interested in sort of hand grasps and things. This has got a big library of all the sort of the grip poses that you can think of, and all the forces that they can apply in various directions, and the sorts of strengths and things like that. So it's very, very useful for making physically simulated hands. Sorry about the font. So these are the mechanics that we're targeting, that we sort of used as a basis for the sort of thing we wanted to do. We wanted to make action movies because Third Floor worked with Hollywood, and that's what they like to do. So we use sort of Mission Impossible, Indiana Jones, that kind of thing as our basis. We're running on the PlayStation VR, the HTC Vive, and the Oculus Rift, so we use the controllers with the triggers. They're all basically the same. They've got various features which we can interpret in different ways, but in order to sort of simplify production for all three platforms, we just interpret them, as you can see, as a position, an orientation, and a trigger value. It's slightly more complicated than that, but for the sake of the talk, I'm going to simplify it down to that. So here's what we can interpret from that. We know exactly where your head and your hands are, but we don't really know where your body is, and we definitely don't know where your legs are. And we've only got very simple inputs. We can output audio, visual, and vibration. So that's all we've got to deal with. It's a very simplified version of the interface that people have with the world. So we start off squeezy trigger to open and close your hand. That's the kind of the obvious thing to be able to do. But what we can do is then grasp. Now, this is basically the first sort of part of how our system works. So we've got these interaction points, and now what an interaction point is, it describes an affordance, essentially. It tells you, here's a place I expect to be able to grab, so we know that when the hand moves towards it, there's a sort of a hover state to the hand to let you know that you can interact with it. And what the system is doing, it's basically looking through all of the interaction points on this object, and it's picking the closest match, and it's saying, well, the user's probably trying to grab at this one, so pick this one. Those interaction points will then send an event to let you know that you've grabbed at that particular point, which you can hook up to whatever functionality you like. So the way that James has kindly authored the system is so that these hookups are automatic if you set up a couple of things beforehand. And one quick example of that, we've got a rotation component. So this is just a rotational constraint, and what it's doing is when the hand grabs hold, it will start looking at where the hand grabbed. And as the hand moves, it will follow where the hand moves with its own constraint. The hand then sort of snaps to the back to the joystick to make sure that it doesn't come off in the animation. Because of the way these components work, they swap in and out really nice and easily. So we can swap a rotation for a positional one. And there you go. It's just riding back and forth. Now, because we're inputting the positional change in the hand, and we're applying it to some kind of constrained motion, after the constrained motion has been applied, there's still a bit of movement that the hand would have applied that was outside of the constraints of the object that you were grabbing. And that can be sent further up the chain, so we can basically just arbitrarily connect these things together and come up with these sort of fun chains of things that sort of slide and move and all that. Now, a slightly more practical use case for that would be a door. So here I've just got a tiny bit of logic which says if the rotation component attached to the blue handle there, is beyond a certain value, then it will unlock the one that's attached to the door itself. So that just allows you to do a simple hinge door behavior. And again here, there's the only scripting there was just a little thing to detect the angle of the handle there and just turn the door, lock the door and unlock the door based on the angle of the handle. So something you obviously notice is we're connecting the hand to the object that we're simulating. So when you're grasping objects in the virtual world, at some point you're going to come across the problem that you've kind of, you can be holding an object and you try and pass it through a wall. And you've got to make the choice of whether or not you're going to leave the object on the same side of the wall, whether you're going to move the object with the hand, or whether you're going to leave your whole hand and the whole object on the other side of the wall. So that's separating your virtual hand from the real hand, so it won't be where your controller is, separating the object from your virtual hand, which is going to look bad, and breaking the object's physical constraint, which is just not going to match the simulation. And also you have problems where if you let something go in a wall, what do you do with it? So you've got to pick one of those and be very conscious that you've got to pick one of those, because if you don't pick one of those, then you're probably going to try and solve them all and you won't be able to. It's sort of logically impossible. Or you can just take the easy option and make the hands disappear when you grab something. So. Here's another system we got, is climbing. Very simple grip and pull based climbing system. We apply haptics based on how much you're pulling downwards, so you'll feel the kind of vibration as you pull down, less so if you're pulling up, and it gives the sort of illusion that you're pulling against a force. And what we can do is combine that with the levers by just nesting them underneath. And here I've created the loft hatch from my house, so you can fold that one down and climb up. So the idea, again, no code at all involved in this. This was purely just plugging those components together nicely in a hierarchy. So here to explain a little bit about how that works is James.
Cool. Thanks, Sam. Okay, it's funny. Even looking at those videos, I'm still sort of bug testing and sort of looking out, oh, is that an error? But no, I think they seemed all right. Okay, so I'm a senior programmer at Third Floor. Similar responsibilities to Sam, but let's go over how they differ. Okay, good. New slides. Right, so as you saw with some of Sam's slides, we've got a hierarchy of objects. We want to be able to interact with each object in a unique way. So one way that we can do that is obviously allow the designers, without writing any code, any scripts at all, just to be able to arbitrarily build up new behaviors, new functionality. So here we've got just a hierarchy, and these could be any objects. They could be a lever, it could be a runner, a slider, it could be something that could be picked up, and you could just layer that out. And so the reason why I haven't marked them as each of those objects, for example, like levers or runners or whatever, is because it doesn't matter which object it is, because they all come down to just implementing an interface. And now I've seen interfaces used quite a lot outside the games industry, but inside the games industry, not so much. You tend to see God objects, and dare I say it, typically worse designs than other areas of software development. So what I'd like to do is really just emphasize the importance of how we can use interfaces. I know it's simple. I'm sure a lot of you already know this, but let's just reiterate it anyway. So the orange ones just implement the interactive object interface, and we'll go over that in a sec. And then the interactor can interact anywhere up the hierarchy. You can see that blue arrow there is one interaction. All the interactor is, in fact, is just to instigate that first interaction. It's not that important. In fact, this is just one way of doing it. There's lots of other ways. We're even devising a system where you don't have an interactor at all, that everything is just an interactive object that can interact with anything else. But the construct of an interactor is quite interesting. It just gives you various conveniences. Again, I'll go through that in a sec. But the idea with these components is they can work across a multitude of different form factors, whether it's VR, AR, mobile touchscreen, mouse, first person. Like we've put a big emphasis on that. So let's have a look at the interactive object interface. So that is the interface for these orange items that you see. Going back to Sam's talks, you saw the nested hierarchy of components. That's what each one of those implemented. This interface was common across all of them. This is just one method on one of those objects. Let's not look at interactive objects just yet. That's not important. We can go over that in a sec. The interactor, however, is probably the most interesting part. You would interact with any object and you would receive the interactor. So you have a direct access to that interactor. So from that you can deduce the transform of the interactor and other aspects. It's also interesting to be able to communicate back from the object back to the interactor. So that's why it's handy just to have the interactor pass through on interactive events.
And we use that for both animation and haptics to sort of pass that back to the avatar and back to the controllers.
Yeah, haptics is a really good example. The other nice thing about this system is that the interactor is completely dumb. All it is doing is just instigating that interaction. It's up to the objects to decide how they're going to behave. And I'll just show you some of the other methods we have on the interactive object interface. So as you can see, let's just look at the downs for now. Down is basically just when you're grabbing down on an object. So you've got on down start, on down stay, which is when you're just moving around, and on down end. Now there's a reason why we've got on down stay. That's just so that we can reduce the state in the system. So it's a stateless design, a stateless branchless design. So that way you grab down on an object, that's on down start. Stay is constantly running on tick, and on down end is when I release it. So that's hopefully fairly simple. That way the module designers don't need to worry about setting a variable or a Boolean flag to say is an interactor interacting with me. Again, a stateless branchless design. Hover, as you would expect, is very similar. It's as you would imagine. So quickly, because we're running out of time, we've got interactive objects. Now that's less important, like I say, but all that is as you propagate up the hierarchy, you have access each time that each time any of these functions is called, then that starts to get populated as it propagates up that hierarchy. Kind of interesting. Ultimately, we're just providing frameworks here for people, unopinionated and flexible frameworks, so they can do anything. A designer may never need that information, but we just want to cover the full spectrum of possibilities. Right, let's move on. Now, just quickly, if anybody's interested in coming and talking after the fact, feel free. This is just an exhaustive or a semi-exhaustive list of features. So if anything there tickles your interest, then please get in touch.
Take a quick picture now if you can.
Say hi. Right, do you want to?
Well, I was going to say there's just a few other bits that we've been working on. So here we've got sort of pushable buttons again. It's all about making as many components for designers as possible. One thing that's probably worth mentioning actually about how you would have seen the events on James's work, it's quite similar to web design. I mean, we're not going to reinvent the wheel. Like sort of hover states and down states and things are generally a good way to implement things. So I think like the idea is just basically steal from every other industry wherever you can.
The CSS standard seems fairly solid across so many use cases.
So these things, again, we're just showing they just connect together arbitrarily. So it's a lot of fun to play around with once you've done the hard work. It was about 6 months, I think, getting it all sort of put together, but now we can have some fun. So again, we're using sort of gravity on a character here, and you've just got a linear constraint, and it sort of all auto-magically works, so it's lovely. So, got time for a couple of questions? Or?
I think we can squeeze in one quick question if anyone has any, or you might have been lucky, you might have got away with it.
Oh, yes, sorry.
Okay, lovely. We can give Sam and James a big round of applause, please.